everybody, it's Shazizz here. I'm going to name this video Electromagnet. Hopefully I don't get the same anomaly that I did earlier where it's messing up my camera from the pulse. But anyway, basically what I did was I took one of these little power supplies. It's a step down transformer from 120 volts AC to 9 volts AC. And what happened was the primary side went bad, and so I basically cut off the little spot weld there. Yeah, you can see it with my Dremel. Cut off the spot weld, and I was able to save the secondary on the deal. Now this right here is not important right at the moment. I'm working on another deal with that. That's a ferrite core that I literally wrapped the cord around just to save some space, and I want to do some experiments to see if I can pull off some more energy off of that that back EMF there as well. But what I want to show you is, everybody knows what an electromagnet is. So essentially I'm going to take this this core right here. These are the wires that came out for the power plug there, for the power outside, the 9 volts, and I'm just going to run them in parallel with my 9 volt battery, positive and negative, which I'm also going to run parallel with this 120 volt strand of LEDs. Now see, when you make an electromagnet, you put that, as long as the DC power is to it, it will hold. Once you let the power loose, it'll obviously let go of the hold there. And so in the process of that, you got a field that's expanding and collapsing. So what can you do with that? They call them magnetic ballasts. They use them in a lot of modern day lighting systems that for the fluorescent portions of them. Now watch as I tap this. Let me see if I can get that voltmeter turned just right. Hopefully you'll be able to see. I'm starting off with a 9 volt battery here, and watch as I tap this. Doggone it, that field's making it all the way there. Alright, let's try a little more powerful battery. And also, that's giving me quite a jolt too. Alright, so you can see the voltage jumps up there. Oh, I also forgot to show you. Let me do that. I want you to notice something here. This is important. Alright, notice that the LEDs aren't on, but the electromagnet's connected. Now watch as I pull this battery loose. You should, okay, if you look real close, watch the LED strand. Ah, seriously? Let's try a stronger battery. I don't know if you can see that or not, but that LED is lighting up as you let the power off. That's that field collapsing. Okay, there it did it. Alright, so what can you do with that? Well, there's a lot of different deals. You could make a kind of like the old jewel thief kind of things that they're doing there, and the toroids and all that kind of deal right there, where you can get the back EMF. This is essentially the same thing as that. It's really no big deal. It's just when you hit the field across it and the field collapses, you pick up that extra energy on the way back. They use it in solenoids and relay switches or relay motors like these right here. I did a video where I was pulsing a little coil with that somewhere. I can't even remember the name of that doggone video either. See if I can get that up there. Alright, so what I'm going to do here I can find it. I'm going to take essentially a solenoid motor, which is a tattoo gun, motor off of a tattoo gun. And if I can remember how I wired this up last time, I'm going to show you something cool. Alright, one of them goes there. And let me see here. There you go. Now watch that LED strand. Doggone it, I don't think you can even see it. Let me turn that overhead light off. It's always when you don't want something, when you want something to work, it don't. Turn that light off. That battery's pretty doggone low. Let me just pop another good battery out there and see if that one of the things about it whenever it's that's the problem. Watch this. This is supposed to guide the magnetic flux lines across. Let me try this in the like that. There you go. Alright, my battery's getting dead on that side. Let me put a better battery in there and see if that works. Brand new battery right out of the box. Cheapo heavy duty Dollar General battery. Let's see if this works any better. So we got a 120 volt AC strand of LEDs, an electromagnet right here, and we're running a tattoo gun. So the tattoo gun, as it's expanding and collapsing on both sides of the coils, is basically putting energy back into the system. Alright, now what? Did I burn up my tattoo gun? It wouldn't surprise me, no. I don't do tattoos anyway. Ah. Maybe that vibrated itself out of whack. Yeah, believe it or not, those things actually have an adjustment on them. Let me turn that little adjustment thing back a little bit, see if that works. This really makes for a terrible video. Alright, I'm going to pause this. Okay, let's try this again before something else falls apart. So anyway, we got the tattoo motor running there, and the this electromagnet is in parallel with that right there. And so the when that field collapses, it's pulsing over on that side right there. So basically that's the same thing that's going on inside that tattoo gun, is that when that field collapses, even though it's connected to this deal, there's still energy bouncing back this direction, and that's why I'm able to do this right here. Let me turn that light there off for just a second. There. So the 9-volt battery is running the tattoo gun. It's running the LED strand, and don't know, let me see, turn the light back on for a second. Lights on, lights off, but watch this right here. Alright, so we got the tattoo gun, the LED strand, and the electromagnet that seems to be weak now. Ah! Boy, I swear. And let's see here. There. Electromagnet. And apparently I got that out of whack again. Alright, well, you get the point. Basically, let me turn the overhead light on. Ah! So you can take any transformer, don't matter what size it is, you cut the top off and you can actually make an electromagnet out of it. When you don't have this on the top right here, that flux can't make it across there, so it's going to be a little bit weaker. So when that's on there, you can actually hear it if, let me see here, one of these doggone batteries was a good battery, and somehow or another I got them mixed up. Alright. Now, if I sit here and tap this, should be able to hear that clicking. That's how basically a relay works. That's how a tattoo gun works. Is there's a spring that allows it to go back, and when the electromagnet kicks on, it pulls down, and then the other one pulls back the other direction, and you essentially got either a solenoid or a relay switch. But you know that when that field's collapsing, I wish you could be here to actually feel whenever this, if you actually have your fingers on these things, whenever you touch them, you get a pretty good little jolt out of it. Put that back on. You see how much stronger that is whenever that core top is back on there? And I'm getting a pretty good little jolt in my finger out of the deal. So it's the field expanding makes your electromagnet, when the field collapses, it actually releases power. So I'm going to try this again. It seemed to have failed me the last several times that I tried it. Let's see if I can do it. Okay, there's my magnet. Let me go ahead and clip one side of this on here. So I only got to touch one side there. Come on there. Seriously? I'm just like off today or something. Out to lunch. Okay. Now, there's the field. I'll watch the LED. If it doesn't make a liar out of me, the LED should blink as soon as I take the battery off. Ta-da! So, with the spring in there, you got a solenoid. That's essentially how that tattoo gun's working. Electromagnet, when that electromagnet's pulsing, as that field's collapsing, I don't know why that doggone camera is acting up like that every time I do it. This magnetic field fluxing across there. Alright, and I don't know what the voltage was reading during that whole entire time. But let's disconnect the power from the LED portion of it and see what kind of voltages we end up with. Keep in mind I'm using a 9-volt battery here, and I'm just pulsing it fast. If you could connect this to a transistor, you could actually do this a little bit quicker, and actually with the potentiometer be able to adjust it down to I don't know if you can see that voltage bit. I actually had this up over 100 and some odd volts earlier. Of course, that was a good battery too. I don't know which one was which. I'm sitting here with a voltmeter and don't know which battery's good. There, did you see that? And that's on the AC side. Darn it, nag screens. You're trying to watch the doggone screen and do this at the same time. It's not easy. It'll make a doggone liar out of me. One of these is a good battery. That direct drain on the electromagnet, it drains these batteries pretty quick. But when you're running that motor and it's not fluctuating, this isn't staying on constant, then the battery lasts a whole lot longer. Alright, well, I'm getting a little shock while I'm doing this anyway. Alright, people, I know that was kind of a messed up video, but you get the point. You can turn any one of these transformers into a electromagnet, but the key that I actually wanted to get out of this video was that when this thing is energized into the electromagnet, when you release that power, it still has energy that bounces back into that LED strand. So that's why you were able to see whenever I had this thing energized that let me see if I got the right doggone wires this time around. Let's try this. Alright, see how weak that is? There's a difference. It's actually sending out a pulse that's messing with the camera. Alright, so when I drop this, that LED should blink like that. So it's holding power there, and when you let go, it releases the back EMF. That's what I want to try to get out in this video. Any one of these transformers, any one of these relays, a tattoo gun, which is pretty much a dual relay switch or solenoid. It's got two different deals. This one sends one coil in. This one is connected, you can see right to that deal. Alright, well, that one powers up first, and when it does, it pulls this electromagnet pulls this down and makes contact. And then when that circuit breaks, as it's going back up, you get that back EMF off of there. That's how it's able to suck back down to both sides like that. Alright, but what we were doing with this deal to be able to keep this on constant was we were running off of the same leads that we were powering it back through the battery and into that, so that we can keep this constant instead of having to use like a transistor or sit there and doing this tapping thing. Let me see if I can hook this up again real quick. One goes to that side. One goes to that side. Nope. Had to burn it. Alright, gonna make a doggone liar out of me again. I'm just not having a good day. Okay. One of them belongs on there. Already connected. Let me pause this for a second. Alright, sorry about that. It'll drive me to drinking, man. I'll tell you what. Doggone it. Gotta get these tattoo guns just right, adjusted. Alright, here we go. Let's try this again. Turn that light off. So, don't it figure? Alright, that's it. I'm done with that. Anyway, basically what I wanted to show you in that whole entire episode, that debacle, was that when you get that back EMF off of that, you can get it off of these coils as well. I had this thing running really good earlier. It's frustrating. But these tattoo guns, they get a little bit out of whack. Things vibrate if you ain't got them adjusted down right. You got to adjust that screw to get this just right in the middle so that it does what it's supposed to do. And apparently it didn't want to do it that time around. So, basically, let me see here. Doing this by hand. Okay, there's the electromagnet let off. Did that burn it? Alright, let's just clip that on there. That's so doggone frustrating. That would be the equivalent of a solenoid. And you can actually see that doggone field messing with the camera. Let's try this with just a little bit more voltage. This is a 9 volt or 12 volt system here. See if that got any more strength. Seriously? This is probably got to be the worst one ever. Alright. Every doggone thing's in the way, ain't it? Now, there it is. Okay, that's enough. That's a simple electromagnet made out of a transformer, and you can actually feed off of some of that energy as the field collapses to utilize it as AC current to run small things like these LEDs right here, and maybe even a fluorescent bulb. But if you used a different like a transistor circuit, or there's a couple other ways you could actually do it. Basically, it's just simply pulsing this coil. Magnetic ballast, they use them in the doggone little small fluorescent lighting fixtures. It's just a little square ballast. Those are already ready to go. If you take one of those things and you... Here, I got one right here. I can show you what they look like. I actually tore this one apart. But these are in those little... fluorescent deals. Of course, I took the top off of this one right here, and just like those right there, if you put it on a 9-volt battery, or any DC battery for that matter, you'll be able to feel a shock coming up out of those as you take your finger off of it. When you take your finger off, you can feel that recoil, that field bouncing back, and it comes back stronger. You can see by the LEDs lighting up. Alright, peace and love, everybody. Stay tuned. Take care. Alright, folks, one little short addendum. This is my little corner of chaos and can't even pronounce it right. Amongst all this madness. So I'm working hard to get back to my normal lab setup so that I can get back to work. I'm trying to work around a bunch of different things. Anyway, this is where I do my radio show, shazizzradio.com. If you want to join me, we can talk some more about this project and many other projects. What I'm trying to point out with a lot of these videos are the individual anomalies that you get when, like the electromagnetic field, when it collapses, and being able to take some of that energy back off of that. And actually, if you pulse that field rapid enough, you can actually light up a strand of 120 volt strand of LEDs, which it's not all that big of a deal if you look at it just in itself. But these anomalies used together and scaled up, you could literally build a solid state generator, like an inverter type scenario, that when you pulsed it with DC using either a solenoid or a mechanical oscillator or whatever, you could actually get a decent charge out of this thing. So it's not the one anomalies by themselves that I wanted to point out. It's if you sit back and you put all these pieces of the puzzle on the table and you look at the big picture. In every single one of my videos, even the crazy ones, I always put something in there that's really important. And if you add the pieces of these puzzles together, you'll figure it out. You'll understand why it is I'm doing the way that I'm doing this, and you'll understand exactly how all this ticks when it's done. So I hope you stay with me and be patient. I'm going to get back into my lab. I got to get out of this. It's closing in on me. It's going to be an avalanche one day, and you won't be able to find Shazizz, and somebody will have to come over and dig me out or something. So I've got family staying with me, so everything's kind of got shoved in over here where it shouldn't be. Anyway, check out my radio show, 8 a.m. to 11 a.m. Central on Saturdays, and 8 a.m. to 11 a.m. Central on Sundays. Saturdays is the Mad Science Show, and Sundays is the Knights of the Round Table. You're welcome to join both, and I'd love to hear from you. And you got questions on any of these videos out here or any of these anomalies, there's tons of podcasts up there that you can listen to that would give you a general idea what it is that I've been trying to point out to people all along. And I would love to put the dream team together. I'd love to get all these people that have all these talents out here together in one lab with the resources, and together I'd say less than 30 days time we could actually have a working device that would satisfy all the alternative energy needs of this world. You know, and I ain't talking no hoodoo voodoo stuff. I'm talking about things that is already proven science, not defying any of the laws of physics, actually using the laws of physics towards our advantage and getting things done. Because you know, as fun as this is meeting everybody out there, I've got a goal in mind, and I've got a lot of projects behind the scenes that are going on, and I've got a lot of videos that need to get done and get out there, and they're on their way, believe me. And when you see what it is that I've been doing all along, and you see what it is that I've been trying to show you, I think you're going to be more than happy. And that's about all I can say about that. So when you watch these videos, pay close attention to the description area in the title, and watch, and you'll understand what it is that I'm doing. Read the descriptions, comment down below, and let's interact back and forth with each other. And when you find something, I've got so many wonderful viewers out there that they point me out to exotic materials and all different types of research. There is so much alternative energy research out there, and if we could get these folks to the table with every single one of these little anomalies, the ones like these little electromagnetic pulses, and then the collapsing of the field, Tesla technology, Bedini circuits, Slayer exciters, and all these different things together. You get these minds together in the same lab at the same time with the materials that they need and the skill set, such as an electrician, a machinist, a mathematician, an artist, and a chef. Somebody's got to cook lunch, all right? Hey, and a singer. We'll have some entertainment. All I'm saying is, if we put the dream team together, it doesn't matter what part of this world we come from. There are brilliant people all over this planet, and if we can get these folks in the right building at the right time, we can give everybody out here, we the people can give everybody what they need as far as clean, renewable, alternative energy. This is why I do this. Alright, come check out my Mad Science radio show on Saturdays. Join in, ask questions. You know, I get trolled a lot, I get cussed out a lot, I get told how stupid I am. But when it's all said and done, I'm going to have the last word on this, because I made a promise to the power company, and I'm going to keep it. Mark my words. Peace and love, everybody. Stay tuned.